All right, so this is going to be our last video covering analyzing polynomial functions. So in this problem set of exercises, or this set of exercises, we're going to put everything together that we've learned. We're going to look at the end behavior. We're going to look at the real zeros, or X-intercepts, their multiplicities, and the behavior at each of these real zeros. And then we're going to sketch a generic graph. So it's not going to be a super accurate graph, but we're going to get a general picture of what the graph of each of these polynomials looks like. Okay, so number one, I have a polynomial that's in factored form. So I'm going to give you these all already in factored form. You don't have to factor them. The first thing we want to do is the end behavior. So I'm going to look at as x goes to infinity, or the right side. What does y do? Well, to figure that out, you're going to take your leading coefficient here. Right, your leading coefficient is 3. So we're going to figure out what y goes to. So since the leading coefficient is 3, that's positive, right? So what can you say about the y value on the right side? On the right side, as x goes to infinity, the y value is going to go to infinity. So when you have a positive leading coefficient, right, positive leading coefficient, your y value goes up, or to infinity on the right side, as x goes to infinity. Okay, now focus on the left side. So as x goes to negative infinity, you can say y does what? That's what we're going to figure out. So let's focus on the degree of the polynomial here. What's the degree? So you're going to take the power of 2 here. You're going to take the power of 1 here, and you're going to take the power of 3 here. So you're going to take all those powers and add them together, right? So you have each of these factors, and you're going to, these factors, powers are sometimes called multiplicities, right? So the degree of each individual factor is called the multiplicities. You're going to take the multiplicity of 2 plus 1 plus 3, 2 plus 1 plus 3, and it looks like we get 6, which is even. So if you have a even degree for your entire polynomial, that means you're going to be doing the same as the right side. The left side is going to be doing the same as the right. So it's going to be the same as the right side. So now you can figure out what y is going to on the left side. Well, remember on the right side, as x goes to infinity, y was going to infinity. So on the left side, so I didn't write this quite correctly, as x goes to, let me rewrite this. Get this to right. Come on. As x goes to negative infinity, that means on the left side, y has to be doing the same as the right side. So y also goes to infinity. Okay? So we got A done. Now we're going to do some B. Let's do some B. So I got these different factors. Oh, come on, piece of crap. I'm going to call this first factor red with an exponent of 2. I'm going to call this second factor green. I'm going to call this third factor, I'll call it yellow, the one with the power of 3. So I'm going to take just the factor without the exponent. I'm going to take x minus a half, set that equal to 0, and I add 1/2 to both sides. I get x equals 1/2. So that's going to be a 0, or an x-intercept, or a root, whatever you want to call it, is a root. Let's call it a 0. Of multiplicity. What's the multiplicity on that 0? Well, look at the exponent there. It has a multiplicity of 2, which is even. Right? 2 is an even number. So that means the graph is going to kiss at x equals 1/2. Thus, the graph kisses at 1/2. Okay, so next we're going to go into the green factor, x minus 1. We'll set that equal to 0. Add 1 to both sides, you get x equals 1. So x equals 1 is going to be a 0, or a root, or an x-intercept, you could say, of multiplicity equal to, what's the power over x minus 1? Well, you don't see a power, but it's understood to be a 1 up there. So just write 1 is multiplicity, which is odd. So that means the graph crosses because we have an odd multiplicity at x equals 1. Thus, the graph crosses at x equals 1. Okay. Finally, I guess yellow is the color. We're going to take x minus 5. Set equal to 0, add 5 to both sides, we get x equals 5 is going to be a 0, or a root, or an x-intercept, however you want to sign that. X equals 5 is 0 of multiplicity. What's the multiplicity? Well, scroll back up. The multiplicity is the exponent of 3 there, which is an odd. So that's going to be another crossing at this 0, so crossing at 5, because you have an odd multiplicity, thus the graph crosses here. Mosquitoes at x equals 5. Okay, so part C, I want to do a generic graph here. I'm going to make a y-axis. I'm going to make an x-axis. I'll make this a little bit neater, maybe. You don't have to be really neat about this, just a general picture. Okay, here's my y-axis, here's my x-axis. So the first thing I'm going to do, I guess I'll put down my zeros or my x-intercepts. So I'm going to have 1 at 1/2, at 1 and 5. So this is at 1/2, 1 and 5. So my graph is going to hit the x-axis in those 3 places. Those 3 places. Now, what do we know about the right end behavior? Well, on the right side, as x goes to infinity, y is going to infinity, so y is going up. So on the right side, we got this kind of arrow here. What about on the left side? On the left side, as x goes to negative infinity, y is going to positive infinity. So on the left side, y is going up. So we got this thing going on the left side, an up arrow on the left side. Okay? Now we know that the left arrow here, the one that's going up to the left, has to come and connect to 1/2, right? It has to hit 1/2. What does it do at 1/2? Well, we said it kisses, right? In part B, we said it kisses. So it's going to bounce off 1/2. And then it has to reconnect to 1. It has to come back and reconnect to 1. Now, what's it going to do at 1? Well, we said it crosses, right? It crosses at 1. So it has to go down and cross at 1. It has to come back, and it has to connect to 5, the graph. Connect to 5. What does it do at 5? Well, we said at x equals 5, it's going to cross. And then it has to connect to that arrow that's going up and to the right. So here's a generic picture. Does the graph look exactly like this? I don't know exactly what it looks like, but this is a good general picture, It's going up and to the right. It's going up and to the left. It hits 1/2 and bounces off. It kisses at 1/2. It comes back down and hits at 1. it crosses over 1. Somehow it comes back up. It goes down, comes back up, it hits 5, and it crosses over 5. We know that. So this is a good general picture of the graph. It's not precisely accurate, but it's a really good overall picture here. All right. So that is number 1, example 1. A lot of analysis there. Example number 2. Let's see, what do I have written here? We have, their function is minus 1/2 x plus 2 x minus 4 to the third power. So first we want to focus on the, what's that called? The right and the left end behavior. So what's happening as x goes to infinity, as x goes to right, what does y go to? Well, we'll figure that out. So since the leading coefficient here, what is the leading coefficient here? So focusing on the leading coefficient for right end behavior, we look at negative 1/2 in front is negative. What does that tell us? You have a negative leading coefficient. Well, as x goes to infinity, as x goes to right, y is going to be going down. So y goes to negative infinity. Okay, now let's focus on the left end behavior as x, if I can get this to right. As x goes to negative infinity, in other words, as you go to the left, what is the y approaching? Well, how does it compare to the other side? How does the left side compare to the right side? Well, since the degree here, what's the degree? Well, I have basically 2 factors. I have the x plus 2 factor and the x minus 4 factor. So the x plus 2 factor has a multiplicity of 1 plus the x minus 4 factor has a multiplicity of 3. So I'm going to add the 1 and the 3 together. I'm going to get a total degree of 4. Since that is even, what can we say about the left-hand side? Well, it's going to be the same, right? You have an even degree. Even degree tells you the left side is the same as the right side. So what was happening on the right side? On the right side, y was going to negative infinity. So on the left side, as x goes to negative infinity, y is also going to be going to negative infinity. It's going to be doing the same. Okay, b. We're going to take each factor and set it equal to 0. So for the first factor here, I have simply, I'll do it in yellow. Yellow, come on, yellow, where are you? We have x plus 2 as our first factor. Our second factor, we're going to have x minus 4. I'll do that in green, let's say. So our first factor here, I'm going to take x plus 2, set it equals 0. I'm going to subtract 2 from both sides. I get x equals minus 2. That's going to be a 0 of multiplicity 1 is a 0. If I can spell that word, 0 of multiplicity 1. Why multiplicity 1? If you look at the factor x plus 2, there's no exponent up above, so it's understood to be a 1 up there. You can imagine there a 1 being up there, which is odd. Right, 1 is an odd multiplicity. So since negative 2 has an odd multiplicity, that means thus the graph is going to cross at x equals minus 2. Okay, I take my second factor, the green one, x minus 4, and disregard the power, the multiplicity of 3. I'm going to disregard that. I'm going to set that equal to 0. I'm going to get x equals 4 is the 0 there. X equals 4 is a 0 of multiplicity. So what is the multiplicity? It's that power of 3 right there, right? A power of 3. That is also odd, which is odd. Now that causes the graph to cross, right? Odd multiplicities indicate crossing at those zeros. Thus the graph crosses at x equals 4. So part C, we're going to graph all this out. put everything together. So here I'm going to have my y-axis. My x-axis. Oops, that's x. That's y. Okay, so basically I'm going to plot down my zeros. I'm going to have a 0 at 4 and 1 at -2, just being really generic, not being super accurate. We're going to have zeros there, 4 and -2. Okay, now I'm going to look at the right end behavior. We said on the right side, as x goes to infinity, y goes down to -infinity. So we're going to be down there, right? Down on the right. On the left side, as x goes to -infinity, y is also going down to -infinity. So we're down here on the left, and basically on the left side, I'm going to start with the left side going down. That has to connect here to -2. What does it do at -2? We said it crosses, right? Crosses. Crosses at -2. So it's going to go across there. And then it has to connect to 4, right? It has to come around and connect to 4. And what does it do at 4? It also crosses at 4. So crosses at 4. Now who knows what the shape is exactly? Who knows? But that's just a kind of general picture. I'm not sure exactly what the shape is. So the idea is on the left side it's going down, on the right side it's going down. It hits, coming from the left, it hits at -2, it goes across. It hits at 4, and it goes across, and then connects to going down. All right, that's number 2 done. Number 3. Do I have a number 3 here? Yep, I have a number 3. So we have a polynomial that's factored 2 times x plus 2 squared times x minus 3/2 squared times x minus 11. So part A, we're going to find the right end behavior and the left end behavior. So as x goes to the right, as x goes to infinity, what does y approach? Well, we're going to focus on the, come on, don't disappear on me, leading coefficient. So look at the leading coefficient, it's +2, right? That's positive. So since the leading coefficient is positive, that means the right side is going up to infinity, right? Y goes to infinity. Now let's look at the left side. As x goes to the left, as x goes to -infinity, what will y do? Well, to determine that, we're going to focus on the degree of the polynomial. So the degree of the polynomial, I'm going to take the multiplicities 2, 2, and 1 and add those together. 2 plus 2 plus 1 is 5. Right, that is odd. So when I have an odd degree, which is 5, that's going to do the opposite of the right side. The left side is going to do the opposite of the right side. So on the right side, y was going to infinity. So the left side, y is going to go to -infinity. -infinity, okay. Okay, so that's done. The right hand behavior, the left hand behavior. Now so let's focus on the different zeros. Focus on the zeros. So let's see, I'm going to have the first one I'm going to call red, the first factor. The second factor I'm going to call yellow. Okay, I'll call it green, and the third one I'll call yellow. That'll be fine. So the first one, I'm going to take the factor without the power of 2. I'm going to set that equal to 0. I'm going to subtract 2 from both sides. I get x is -2 is a 0 of multiplicity 2. Right, multiplicity 2, that's that power of 2 up above the factor, which is even. So even multiplicity indicates kissing at -2. So thus the graph kisses at x equals -2. Okay, I'm going to go into the green factor, x minus 3/2, and disregard the power of 2 for now. I'm going to have x minus 3/2 equals 0. I'm going to add 3/2 to both sides. I'll get x equals 3/2. That's going to be a 0, or you could call it a real root, or you could call it a x-intercept. That's a 0 of multiplicity 2. So again, we have a power of 2 up there, which is even. Which is even. So that means here that we're going to kiss at 3/2. Thus, the graph kisses at x equals 3/2. 3/2 is the same thing as 1.5, right? You can think about that as 1.5. And finally, this yellow piece, we take x minus 11. So that equal to 0. Add 11 to both sides. You get x equals 11 is a 0, or a root, or an x-intercept of multiplicity. What's the multiplicity on this one? Let's go back up and check real quick. So you don't see any power above, but you can understand that there's a power of 1 up there. Multiplicity is 1, which is odd. So an odd multiplicity indicates the graph kissing there at 11. Thus, the graph kisses at x equals 11. So here I'm going to put everything together for my generic graph. X-axis and y-axis. All right, I'm going to put down my my intercepts, or my what do you call these? My zeros. So I have an x-intercept or a 0 at -2. I have one at 3/2, which is the same thing as 1.5. So I'm going to write 3/2 as 1.5. And I have one at +11, so I'm going to write that like way up here, okay? So I'm going to put some points there, some red points. That's going to be part of my graph. Now, I'm going to do the right-hand behavior. So as x goes to the right, as x goes to infinity, y goes to infinity. So on the right side, we're going to be going up. Okay? On the left side, as x goes to -infinity, y goes to -infinity, y goes down. So on the left side, y is going down, so we're going down. Okay, so going from left to right, from this down arrow, I'm going to have to connect to -2, required to. Now, what do we do at -2? Did we kiss or did we cross? We kissed at -2, so I'm going to kiss. That means I'm going to hit -2, bounce off, and come back down. And now I'm going to have to come back up and connect to 1.5. Now, what do we do at 1.5? What does it say? That's the same thing as 3/2. 3/2. We kissed at 3/2, right? So we're going to kiss. We're going to kiss 3/2 or 1.5, and we're going to come back down. So now we have to reconnect with 11. We have to connect with 11. What do we do at 11? The graph should have crossed. Why did I write kiss? I don't know. Should have crossed. Why should have crossed? Because we had an odd multiplicity, right? Odd multiplicity means you cross. I don't know why I said kiss. So we should be crossing there. We should be coming across there. 11. And then connecting to that up arrow. Yeah. So I don't know why I wrote crosses earlier for odd. Yeah. Odds always cross. All right, so there's your final graph. That's a good overall picture of what it looks like. So everything's not perfect with this graph, but I mean it has the general shape of your graph. On the right side, on the left side, and then the kissing at -2, the kissing at 1.5, and the crossing at 11. All right, what was that? Number 3? Yeah, it's number 3. Let's do a number 4. See if I have a number 4 here. Here's my function f of x equals minus x plus 1 squared times x minus 8. So what do we do first? First, we're going to look at the end behavior. So right end behavior and then left end behavior. So on the right side, as x goes to infinity, what does y do? Well, we're going to focus on the leading coefficient. So since the leading coefficient, the LC is -1, right? You have a -1 right here. Is negative. Since the leading coefficient is negative, what can we say about the y value on the right side? Well, the y value goes down. Y goes to negative infinity. So as x goes to infinity, y goes to negative infinity, since the leading coefficient is negative. So what about the left side as x goes to negative infinity? What would y do? Well, we're going to focus on what's comparable to the right side. What will the left side do compared to the right side? Well, since the degree here of the polynomial is, so what's the degree? You're going to take 2 here plus 1 here. Add up those multiplicities, get a degree of 3 overall. That's odd. So odd degree indicates opposite of the right side. It's going to be the opposite. And the left side is going to be the opposite of the right side. So the right side was going to negative infinity, so the left side must be going to positive infinity. So as x goes to negative infinity, y goes to positive infinity, we can say. Okay, so that's done. Get rid of some of these marks here. Now what do we do next? I think we do the zeros, right? The zeros. So I'm going to take, basically I'm going to have x plus 1 squared as my first factor, and my second factor is going to be x minus 8. I'm going to take x plus 1, the first factor without the square. I'm going to set that equal to 0. I'm going to subtract 1 from both sides. I get x equals minus 1. Is a real 0. Or we'll just say a 0. I'll just say a 0 rather than a real 0. You could say it's a root. You could say it's an x-intercept. However you want to say that. X equals minus 1 is a 0. With multiplicity 2, right? That's that power up there, 2, which is even. So that's indicative of kissing at -1, right? Thus, the graph kisses, right? Because even multiplicities, multiplicity of 2, which is even, causes it to kiss at -1. The graph kisses at x equals -1. Okay, I go on to my red factor, which is x minus 8. I'm going to set that equal to 0. I'm going to add 8 to both sides. I'm going to get x equals 8. That's going to be a 0 of what multiplicity? Well, what is the power above our factor? So x minus 8, we don't see a power, but it's understood to be a 1 up there. So it's multiplicity 1, which is odd. So odd multiplicity indicates crossing. Say it correctly and write it correctly this time. Thus, the graph crosses odd multiplicity at x equals 8. So when I graph all this out, it's going to be part C. X-axis, y-axis. I'll start with my 2 intercepts, or my 2 zeros, or my 2 roots. I'm going to have one here at -1, and I'm going to have one here up at 8. I'll put red dots there to indicate my graph is going to hit at those zeros, those intercepts. Okay, now I'm going to focus on my right-hand behavior. So as x goes to infinity, as x goes to the right, y goes to negative infinity. So on the right side, y is going down. So we're going to have a down arrow. And that's going to have to connect to 8. Okay, now the left side. As x goes to negative infinity, y goes to positive infinity. So y goes up on the left side. So on the left side, we have an arrow going up, and that's going to have to connect to what? -1. -1. Okay, now what else can we do here? So at -1, we know we're kissing, right? We're kissing. So the graph kisses at -1. So we're going to bounce off of -1. We're going to come up, and then we're going to have to reconnect to 8. Right, we're going to have to reconnect to 8 somehow. And what are we doing at 8? We're crossing, and that's exactly what it says, right? We're crossing it. So there's a very generic picture of what your function would look like, your polynomial function. All right, so that's it for generic graphs, polynomial functions, analyzing.